Hello, we will present our work, Reaction or Speculation, building computational support for users in catching up series based on an emerging media consumption phenomenon. I'm Riku Arakawa, and this work was done with my colleague Hiromu Yakura. First, I would like to share how this project started about 2 years ago. I was watching a Japanese serial TV show as a catching up user on Hulu. It is a fictional narrative set in an apartment building where serial murders occur. After watching the episode 4 out of 20 episodes, I googled the show just to see discussions on the clue for the murder I found in the episode. In other words, I was doing speculation. However, I encountered an article that presents the ending of the TV show, which is a spoiler. I realized that while speculation is a fun activity, it is dangerous for catching up users. From this experience, we started this project to elucidate how people are enjoying speculation and how we can leverage this phenomenon for supporting catching up users. Let me talk about the background. In recent years, it is becoming difficult to assume that many people enjoy media content at the time that it is distributed. Instead, a growing number of users are choosing to catch up after the first airing using catch-up TV website hosted by the networks or on other video distribution services such as Amazon, Netflix, and Hulu. Considering the demand for catching up on the content of the series, we suspect that there is an excellent opportunity to address the needs of catching up users through computer-supported approaches. We first reviewed the articles about social experiences in media consumption from two aspects, sharing immediate reactions and sharing speculations. In fact, sharing immediate reactions is a well-explored field in HCI. It basically aims to invoke the feeling of watching TV with peers by sharing reactions in real time. For example, prior works propose audience silhouettes when users watch tennis games, or analyze how Twitter is used while watching soccer games. In addition, dynamic commenting is a popular interface and is known to create a pseudo-synchronized viewing experience. On the other hand, little research has focused on sharing speculations to date. A few studies examined specific TV dramas where speculation happened on the internet, such as fan community or fan wiki. Here, we find several research gaps when we consider how to support catching up users based on the speculation phenomenon. For example, we do not know whether catching up users appreciate such stored discussions. It is also possible that social networking services have significantly transformed the ways of media consumption related to speculation. Therefore, to understand how people are engaging with speculation on the internet during media consumption experiences, we conducted semi-structured interviews first, where we asked questions such as how do you engage with speculation and how often do you engage with speculation. As a result, we identified three key findings regarding how they engage with speculation. First, participants like speculation for deepening understandings of media content, saying, I googled the title with the word kousatsu, meaning speculation in Japanese, and jump to them. Also, they mentioned various platforms such as personal blogs, Twitter, and Instagram. Secondly, they are feeling a sense of connectedness with others who are engaging with speculation. For example, one participant mentioned, on Twitter, I can see speculations posted just after the broadcast. I like this sense of liveliness with other users. Here, user behaviors could be divided into posters and lurkers. Posters are actively involved in speculation and discussion with other users, whereas lurkers merely consume speculations posted by other users. Lastly, they have concerns about encountering spoilers, as I did, especially when they want to engage with speculation during catching up, saying, I would like to take a look at speculations for each episode in order to savor it, but given the risk of spoilers, it's hard to do. The participants expressed complaints about spoilers or at least wished to control their exposure to such information. These findings imply that online speculative communication has distinct characteristics to what the previous research discussed and requires a specific computational support.
To confirm this point quantitatively, we conducted tweet analysis. Based on the comments suggesting that Twitter is widely used for sharing speculations with dedicated hashtags, we collected tweets about 2 TV series. Then we compared the characteristics of speculation and non-speculation tweets. Here, speculation tweets refers to tweets containing hashtags that concatenate the title with kosatsu, speculation in Japanese. On the other hand, non-speculation tweets refer to tweets containing just the title. This time plot illustrates the timing of the tweets were posted. The gray area denotes the airtime of the TV show. When we focus on non-speculation tweets, which is the orange line, we can see that their peak volume was on the airtime. However, from the green line, we can see that speculation tweets were actively posted within a few hours after the end of the broadcast. Such a lingering occurrence is not mentioned in the previous research, and it is unique to speculation tweets. From this point, we can infer that viewers discussed forecasts about what will happen in the next episode, rather than sharing immediate reactions using the dedicated hashtags for speculation. We also investigated the content of the tweet. We first found that speculation tweets consisted of significantly more characters than non-speculation tweets. This also suggests that speculation is contrastive to the sharing of immediate reaction. In addition, we found that speculation tweets contained more hyperlinks. For example, about 15% of speculation tweets attached images as the form of hyperlinks, which are mainly intended to provide grounds for speculation via capture shots. Also, about 4% cited other tweets as a form of hyperlinks so as to develop the discussion within multiple users on Twitter. Furthermore, we observed links to blogs and other media in which long writings about the forecast of the consequence were posted. This investigation also informed a new usage of Twitter in which the screenshots of a note-taking app were attached as shown. This user intended to share long speculative comments in a single tweet and took this approach. These results suggest that while social networking services succeeded in engaging users who want to share their speculation, its function would not be optimal. In addition, as we found in the semi-structured interviews, the risk of spoilers still remains, especially for catching up users. Therefore, we developed supporting interface for catching up users based on what we observed about online speculative communications. Specifically, we introduced 2 types of interfaces. One is to be used while watching to provide the feeling of connectedness. The other is to be used between catching up each episode to provide a deeper understanding of content. Our user study revealed that distinct efficacy of these 2 interfaces. For further details, please refer to our paper. There are our takeaway messages. Thank you for listening.